Hello everyone, in this video, I will solve question 3 in homework 1. For question 3, we are given the following information. A digital signal 1 or 0 is transmitted through a noisy channel. The received data may be different from the signal sent out. Suppose the transmitter sends out 0 with probability 0.6 and 1 with probability 0.4. When the signal 0 is transmitted, the receiver receives 0 with probability 0.7 and 1 with probability 0.3. When 1 is transmitted, the receiver received 0 with probability 0.2 and 1 with probability 0.8. In this question, we need to solve two problems. The first one is to find the probability that data 0 is received, and the second one is to find the probability of error. In order to solve these two questions, we need to understand two things first. So the first thing is the multiplication rules of probability, and the second one is the addition rules of probability. For the multiplication rules of probability, the formula as follows. The multiplication rules of probability applies when we want to find out the chances of an intersection of two events. That is, the chances of both of them will happen, as can be seen from this formula. The probability of A and B equals to the probability of A times the probability of B happening, given that A has already happened. And for the addition rules of probability, its formula is written like this. The probability of event A or event B happening, which is the probability of event A plus the probability of event B. The addition rules only for mutually exclusive events. So what does mutually exclusive events mean? That is, if two events cannot occur at the same time, that we can say they are mutually exclusive. Now let's go back to our question. First, I need to set some notations to simplify this question. In this case, the T0 means signal 0 is transmitted, and the T1 means 1 is transmitted, and the R0 means signal 0 is received, and the R1 means signal 1 is received. According to the information from this question, we can know that the probability of T0 equals to 0.6, and the probability of signal 1 transmitted is 0.4, and moreover, the probability of receiving 0 sent by signal 0 equals to 0.7, and the probability of receiving signal 1 sent by 0, that equals to 0.3, and also can let we know the other thing is the probability of receiving signal 0 and transmitted by signal 1 is 0.2, and the probability of receiving signal 1 transmitted by signal 1 is 0.8. For question 1, to find the probability that data 0 is received, and I need to combine the multiplication rules of probability and addition rules of probability to solve it. First, I can calculate the probability of receiving signal 1, signal 0 sent by signal 0. That is equals to 0.7 times 0.6. That equals to 0.42. And to calculate the probability of receiving signal 0 transmitted by signal 1, I can get that probability is equals to 0.4 times 0.2. That is 0.08. And so the probability of R0 is equals to 0.42 plus 0.08. That is 0.5. Finally, let's look at the second question. To find the probability of error. Here we have two error conditions. The first one is when zero is transmitted, we actually receive 1, and condition 2 is when 1 is transmitted, we actually received 0. So the probability of error happens should be equals to the probability of that is the signal 0 is transmitted and 1 is received. So it should be the probability of T0 times the probability of R1 happens given by 0 is transmitted plus the probability of T1 multiplies the probability of receiving signal 0 given by sending 1. And this equation finally equals to 0.26. There is the answer for the question 2.